Let's use the units to indicate which variables are given. Kilopascals is a measure of pressure. Celsius is a measure of temperature. We have another Celsius, so this is a change in conditions of a gas. So we have T1 and T2, and we're told the volume is constant. So we can start with the combined gas law, which goes as P1 V1 over T1 is equal to P2 V2 over T2. And we can cross out the variables that are constant. In this case, is volume. So we're left with P1 over T1 equals P2 over T2. This is also known as Gay-Lussac's law, which states that pressure is directly proportional to temperature. If one goes up, the other goes up. If one goes down, the other goes down. Gas laws are proportionality statements, so we need to use absolute scales, not scales which arbitrarily chooses 0 to be some point. So we need to convert our temperature values from Celsius to Kelvin. We can do that by adding 273. So 22 degrees Celsius is 295. Let's add 273 to T1, and that'll take us to 314 Kelvin. The question is asking us to solve for the second pressure, P2. So let's rearrange this algebraically to solve for P2. The second pressure is going to equal to P1 times T2 over T1. Now let's plug in our values. P1 is 108 kilopascals. T2 is 295 Kelvin. And the initial temperature is 314. The Kelvins are going to cancel out. Our answer should have 3 sig figs, because each of our measurements given have 3 significant figures on absolute scales. So 101 kilopascals is our answer, which is about 1 standard atmosphere pressure. So let's see if this makes sense. Our original gas lowered in temperature, so our pressure should also have decreased, and it did. It went from 108 to 101.